Hey, what's up everybody? My name is Moss, and in this video, I'm going to continue our series on how to secure OpenClaw. If you haven't seen the first video, I encourage you to take a look at it. It's fairly short, and I've linked it in the video description below. In that video, I described several ways that you can lock down and secure your OpenClaw instance. And today we'll explore some of those methods. The first thing that you should do is create a dedicated user that the OpenClaw instance will run as that's non-root, and then adjust your host file system permissions to control what that user has access to. This is a really simple, straightforward way that provides defense in depth and is extremely effective. The other two methods are OpenClaw native functionality called tool policies. You could think of these as first level defense mechanisms against OpenClaw operating in a way that you don't want, with host file system permissions as a fallback to catch anything that the tool policy doesn't catch. The first tool policy is file system group, which includes several tools, including read, write, edit, and apply patch tool. And together, these tools are every native way the agent can touch files through OpenClaw's tool layer. And then the second tool policy that we'll cover is the runtime group. The runtime group is every tool that lets the agent execute code on your system, which would include exec and process. So you can allow or deny OpenClaw access to tools in these groups. I'm currently connected to the OpenClaw instance as the Ubuntu user, and OpenClaw is also running as this Ubuntu user. For this case, the Ubuntu user serves that purpose just fine. One thing to keep in the back of your mind is that by default, OpenClaw runs the agent inside a Docker sandboxed container. So everything we do in this video is happening inside that container and not on the host machine. That detail will be important later on. And I have a couple of scripts that I've already applied permissions to. Let's take a look at those. So if we look at the permissions of these two scripts, the Hello World script is accessible. It's readable and executable by other users on the system, including the Ubuntu user, but it is owned by root. And then the second script is read-write executable, but only for the root user. No other users on this system can access it. So what we would expect when I'm chatting with OpenClaw, if I ask it to read, write, or execute the secret.sh file, it will not be able to because the user that OpenClaw is running as doesn't have access to it. So let's navigate to the OpenClaw web UI where we can chat directly with this OpenClaw instance. Okay, so here is the OpenClaw gateway dashboard where I can chat directly with the OpenClaw instance, and I can also, it's kind of like a control plane where I can manage OpenClaw through this interface. First, let's make sure that we can read and execute that Hello World script. I'm going to increase the zoom here on my browser a little bit. After I ask it to read the Hello World script, it invokes the read tool, and then it prints out to the chat what is in that Hello World script. Now let's confirm that OpenClaw can execute that script. After asking it to execute the script, it invokes the exec tool, and you can see here it says run bash and then the script, and that was successful. It prints it out and it provides the output from the terminal to this chat interface. Now let's have it read the secret.sh script. So as expected, when OpenClaw tries to invoke the read tool to read the secret.sh, the file system returns a permission denied error, which is correct, and that's what we want to see. Now, the next thing that I'm going to do is apply a new tool policy that denies it the ability to access the file system tools. So that group FS tool policies are going to be denied. And the configuration for the group file system is in this stage 3 configuration file for OpenClaw, and I'm going to compare the current configuration with stage 3. So at the bottom of the file is the diff between these versions. And in stage 3, what we're adding here is a deny policy, a deny tool policy, all of the tools that are in the file system group. And those tools are read, write, edit, and apply patch. So I'm going to run a convenience script to apply that configuration. So let's navigate back to the web UI, and I'm going to refresh the page. So I haven't changed host file system permissions. The Ubuntu user that OpenClaw is running as still technically has read and executable access to the hello world.sh file. However, I just applied the file system group tool policies to deny, read, write, edit, and apply patch. So this is OpenClaw's like native functionality that it should deny OpenClaw from being able to access that script file. Okay, and this is the output that I was hoping for. If we scroll up to the beginning, OpenClaw tries to invoke the read tool, which it doesn't have access to anymore. It says tool read not found. And then it responds to me. It says, it looks like the read tool is not available at the moment. Let me try using a different method to read the file. So I didn't even ask it. It immediately tried to pivot to the exec tool to still essentially cat the contents of the file back to me in the chat output. And so this is a good demonstration of how dangerous OpenClaw can be. It didn't ask me for permission to run the exec tool to expose what's in the hello world script. Could have been sensitive keys or API tokens. So I'll navigate back to the editor. And let's do a diff between the stage 3 configuration and the one that we are about to apply. And you can see in this configuration that we're adding the runtime group tool policies to the deny list. I'm going to run my convenience script to apply this new configuration. And let's navigate back to the web UI, and I'll refresh the page. And I'm going to ask it to read the hello world script again, and let's see if it tries to invoke the exec tool as well. And this time around, it skips over trying to invoke the read tool because it knows it doesn't have access to that. And immediately tries to invoke the exec tool. And we get confirmation that the exec tool is not accessible to it. Now there's a trade-off here. Most of why you would want to use OpenClaw in the first place is the agent being able to do things, on your machine. So if you take that away, what's left is, mostly just a regular chat LLM. It can still answer questions from its training. It could summarize text or images that you paste into the chat. And if you've allowed some of the other tool policies like the web tool policies, it can even hit the internet for searches and page fetches. So it's more useful for read-only assistance. However, there is a middle ground between this trade-off of security versus functionality, and that's called elevated mode plus approvals. So the agent stays sandboxed and fully capable inside of the sandbox, but anything that wants to break out and touch the host system has to be approved by you first. So let's navigate back to the editor, and I'm going to apply the final configuration. And let's do a comparison between stage 4 and stage 5 configuration files. So the stage 5 configuration file swaps out the deny list entirely and introduces a new block, which is the tools elevated block. This is what unlocks elevated mode. We're enabling it to true, and we're saying that anyone who's connected through the web chat interface is allowed to ask for elevated mode. Now, what does this mean to be in elevated mode? Up to this point, the agent has been running everything inside a Docker sandbox. And you might be wondering, but the agent has been reading, scripts from the ops scripts directory and executing those scripts. Hasn't it already been connected to the host that it's running on? But the answer is no, because that ops scripts directory is bind mounted into the sandbox container read-only. The agent has been seeing those files through a controlled window into the container, but it's never actually been on the host. So when we were running like cat and executing the file, executing the scripts, the exec tool was executing inside of the sandboxed container. But when the agent goes elevated, exec calls stop going to the container and they start going to the real host machine. So you're actually invoking binaries that are on the host machine, and that can become, more dangerous, right? Because you're actually exposing OpenClaw to the host machine's environment. And this is where a second configuration file comes in called execapprovals.json. So let's take a look at this configuration file and specifically the defaults block. This controls what happens when an elevated command hits the host. And it's separate from the main config because it also stores per host plumbing and the dynamic allow list of commands that you've already approved. And there's 3 settings that matter. The security allow list means commands are denied unless they match an allow list. And currently ours is empty, so nothing matches. The ask always means every single command pops a prompt. Okay, so it's going to pop up with a prompt to approve or deny that command execution. And then the ask fallback deny just means that if the prompt UI isn't available for some reason, we fail closed. So together, these config files basically mean web chat users can request elevated mode, and if they do, every host command needs approval. So let me navigate back to the web dashboard. And here I'm going to type in the elevated command and ask. And then we get a confirmation message that says elevated mode set to ask, approvals may still apply. So it's telling OpenClaw 2 things. Number 1, route my exec calls to the host instead of the sandbox container, and then keep approval prompts active. And there's also an elevated full which routes to host but skips approvals. That's obviously dangerous. So we don't want to use that unless you really know what you're doing or you're in an environment that is kind of like a throwaway environment. So now I'm going to try to have OpenClaw execute that hello world script again. And this is perfect because now I'm in the loop on every command that wants to run outside of the container sandbox and on the host machine. So I can allow once, I can always allow, or I can deny the command. We know exactly where the command is going to run. We know what the command is, and then there's also an expiration on the approval as well. So I'm going to select allow once. Okay, so now that I've approved that command to run, let me tell it to proceed. So we can see in the system message that the exec completed. Here's the output in the system message, and then also in its response back to me, it provides the output from the script. So in the initial configuration, as far as OpenClaw was concerned, there were no tool policies set to deny it from executing files or reading files, but we did have file system level permissions applied to bind-mounted files from the host machine, which was the hello world script and the secrets.sh script. In the next iteration, we actually added a tool policy to explicitly deny the file system group tools, which were the read, write, edit, and apply patch tools. But because OpenClaw is too smart for its own good, it simply invoked the exec tool, which it still had access to essentially cat the file to the terminal, to the chat window. So we then applied both the file system group tool policy as well as the runtime tool policy to the deny list. And in the final state of the configuration for OpenClaw, we applied a more productionized configuration using elevated mode plus approvals. And so that's the middle ground that I think most teams utilizing OpenClaw or most individuals would want to have. I hope this video was useful, and we've got more videos coming in the series, so stay tuned and be sure to subscribe so that you can catch them as they are released.